Okay, this section is chapter 3.6. We're going to be going over polynomial inequalities. So the nice thing for this section is for polynomial inequalities, we're only going to be dealing with polynomials of at most degree 2, which means they're going to be degree 1, which are linear inequalities, or degree 2, which are quadratic inequalities. So we're going to be setting up our inequality, so it's going to look like one of these four setups. It might not look like this right away, but we're going to rewrite it so it looks like one of these four setups. F of x, where f of x is the polynomial, is less than 0, f of x is greater than 0, or f of x less than or equal to 0, and lastly, f of x greater than or equal to 0. So one of our first steps, which we'll see more formally on the next page, is going to be having 0 on one side of the inequality. So unlike equations, our answers here our answer is going to be an interval. We're going to be finding the intervals of x values that makes the inequality true, and the answer is going to be an interval notation. So in order to find out when the function is greater than 0 or less than 0, we're going to first have to also find out when the function just equals 0. These are technically called boundary points. All these actually are these boundary points when a function equals 0. These are x-intercepts. So we're going to have to find the x-intercepts, or what they're called for these types of questions are boundary points. Find the x-intercepts for these functions. And for this other part where it says create a number line and choose test values, the way that I'm actually going to do it is draw a graph instead, but you can use a number line and test values as well. So let's see this first example where we're given the function, but we're also given the graph, just so we can see that when we're given a graph, the question becomes a lot easier. So let's say we have the function f of x, which is x squared minus 7x plus 10, which of course, notice this is a quadratic function. And let's use the graph to find the intervals when the function is less than 0 and greater than 0. So two separate things. We want to know when is the function greater than 0 and when is the function less than 0. So the reason why having the graph in front of us is going to be a lot easier is because less than 0 is going to be when the function is, this one right here, less than 0 is going to be when the function is just below the x-axis, because that's when the y values or the function values are negative. So when we have the graph, we just have to know that the function being less than 0 is when the graph is below the x-axis. That's going to be the highlighted portion over here. And this interval here, remember, it's only x values that we're going to be using when we're writing the answer in interval notation. That's going to be the x value from 2 to 5. So f of x is less than 0 on the interval 2 to 5. And then one other little thing we have to be careful for, notice that I put parentheses here because we're not including these endpoints, because when we include the endpoints, that would mean that that's when the function equals 0. But since this is only less than 0, not less than or equal to, we're only using parentheses. So same idea now with, and just notice that I just have these labeled over here. These are the boundary points, the x-intercepts of 2 and 5. And then for the one on the left here, f of x greater than 0, we know a graph is greater than 0, a function's greater than 0, when the graph is above the x-axis. So looking at these two highlighted regions over here, since we have arrows going to the left and going to the right, we know these are going to be involving infinity or negative infinity. So the first interval on the left is negative infinity, and then it looks like it goes to this the boundary point of 2, and then union or comma, and the second interval over here on the right is going to be starting at the boundary point of 5, and then it's going to continue going forever to infinity. So these are the two different intervals here for when the function is less than 0 and when the function is greater than 0. So hopefully you agree that having the graph in front of you makes these questions a lot easier. So let's go ahead and see these generic steps, and then we'll see some examples where we're not given the graphs. So the first part, for step 1, we're going to have to express the inequality in one of these forms. And what that means is we need to get 0 on one side by itself, just like we had on the previous page at the beginning of the page. That means we're going to have to add or subtract terms to both sides of the equation, or the inequality rather, to move them to the other side of the inequality. So something to keep in mind that's a very good idea is we should move the terms on the side of the inequality that makes the highest degree positive, or the highest exponent positive. And we'll kind of see why that is when we do these examples. It's going to make either graphing them or solving the x-intercepts a little bit easier. So that's step one, getting 0 on one side by itself, everything else on the other side. The second step is essentially finding the x-intercepts, which once again are technically called boundary points for this question, but we just take the function and set it equal to 0 and then solve for x. And then step 3, this is where I'm going to differ just a little bit. Step 3 and 4, let me just kind of do a little bracket here. I'm going to do this a little bit differently. I'm actually just going to draw a graph instead of creating a number line and choosing test points. The reason why drawing a graph is going to be easier for us for these questions is because we're only dealing with linear or quadratic functions, which makes graphing them pretty simple because we know how to graph linear and quadratic functions. And then step 5, once we have the graph, we just do it just like we did the previous one. We just kind of read off the solution set. We just have to determine, are we looking for when the function is greater than 0, less than 0, or greater than or equal to, or less than or equal to 0. And then the last little tricky part is if you have greater than or equal to or less than or equal to 0, we have to include the boundary points using brackets instead of parentheses. So let's go ahead and see these steps in actions. Let's go ahead and solve x squared minus x greater than 20. So once again, the first step is we want 0 on one side of the inequality. And we know that we should get every term on the left side of the inequality because the x squared term is already positive. So that means we're just going to have to subtract this 20 to both sides. And we get x squared minus x minus 20 greater than 0. And this right here on the left side, this is our function. Once we have this once we have everything on the same side and 0 on the other side, we're going to take this function. And once again, these are just x-intercepts that we're going to be finding. I'm just going to label them boundary points because we just call them boundary points. We just set this function equal to 0 and we solve for x. So we know how to solve this. We hope that we can factor. It does look like this factors to x minus 5 times x plus 4. Set both of these factors equal to 0 separately. We get negative 4 and positive 5. So once we have these boundary points, this is where instead of creating this number line and choosing some test values, what I'm going to do here is just draw a really rough sketch of this function. F of x is x squared minus x minus 20. The reason why it's very easy to draw this rough sketch is, first of all, we have the x-intercepts, which of course this doesn't have to be perfectly to scale. We have the x-intercepts, negative 4. I'm going to draw these a little bit closer to each other. Negative 4 and positive 5. And the only other thing that we need to know here is if the polynomial opens up or down. We know that this polynomial opens up because the x squared term is positive. So we know this function looks something like this. We don't care what the y-intercept is. We don't care what the vertex is. We only need to know these two things in order to graph it kind of accurately, the x-intercepts and if it opens up or down. Once we have this, now we just go back to the original question over here on the left. We want to know when is it greater than 0. Greater than 0 means it's above, the graph is above the x-axis. So greater than 0 is going to be these highlighted intervals over here on the right. And that's going to be the intervals, let's take a look at the first one over here on the left. That's going to be the interval negative infinity to the boundary point of negative 4 with a parenthesis because we're not including the x-intercept of 0. And then union, then we have this other interval right here, which is the boundary point from x equals 5 and then it keeps going to infinity. And then we're actually done. So once again, these questions are going to look very similar every time we do them. We want to get everything on the same side, so zeros on one side of the inequality. We want the highest degree term to be positive. Then we're going to find the boundary points, or the x-intercepts. Then we're going to do a really rough sketch. And if we do this the same way, where the highest degree is always positive, then the parabola should always be opening up. That's why doing it the same way is going to make it a little bit easier. And then we just have to figure out based on the graph, in this case, when is it positive, and then just write out the answer in interval notation. So let's go ahead and see a few more. Next one, maybe get a little bit harder. 2x squared plus x greater than or equal to 15. And once again, we want to get everything on the same side, so zeros on one side by itself. Since the x squared term is already positive on the left, let's get everything on the left, which means we need to subtract 15 to the left-hand side. So 2x squared plus x minus 15 greater than or equal to 0. So just like before, now we're going to think of that left side of the function, left side of the inequality rather, as a function. And we're going to find the x-intercepts, or the boundary points. So we're going to set it equal to 0 and solve this for x. So just kind of a quick reminder, let's go ahead and try to factor this. Remember that the quadratic formula always works for the quadratic equation. So you could use the quadratic formula here, and it's going to work. So if you want to try that, go ahead. But just for a quick reminder of how to factor this, a couple different ways. It starts, I do it by grouping. We split this middle x term into two separate terms, and we need to figure out what these coefficients are, and then we need to factor this by grouping. So these two coefficients are going to add, they're going to add to the original coefficient, which is 1, and then instead of multiplying to negative 15, it needs to multiply to the product of 2 times negative 15, so negative 30. So for the multiplying portion, it always has to multiply to the product of the leading coefficient and the constant term. And two numbers that add to 1 and multiply to negative 30, that looks like that's going to be positive 6 and negative 5. So positive 6 and negative 5. And you could put those in whichever spot you want. You can you can switch spots and you'll end up getting the same thing. So when you factor this by grouping, remember for grouping, we do the GCF of the first group, GCF of the last group separately. The GCF of the first group is 2x. If you factor out a 2x, you're left with x plus 3. Second group, if you factor out a GCF of negative 5, you're also left with x plus 3. And in order for grouping to work, these parentheses need to be the same. So you factor out the x plus 3, and we're just left with 2x minus 5. So all that work, hopefully not too bad, was just in order to factor that expression on the left. And now we set both of those factors equal to 0 separately. We get negative 3 and positive 5 over 2. So just like before, now we're going to do a really rough sketch of this graph, and it's going to become just as easy as it was in the previous one. So negative 3 and 5 halves. Once again, this is not going to be drawn to scale by any means. And the function that we're graphing is a parabola, is a quadratic, so the shape is going to be a parabola. This is going to be a parabola opening up once again. So it's going to look something like this right here. So now we just need to go back to what we're actually trying to answer here. We're trying to find when is this greater than or equal to 0. And then just pretty similar to the previous one, that's going to be above the x-axis, which is those two intervals right here. So the first interval that we have is this one on the left. That's going to be negative infinity to negative 3. But we do have to be a little careful. Since we have or equal to, negative 3, the x-intercept is actually also a value that satisfies this inequality. So we have to put a bracket. So negative infinity to negative 3. and then union. And then the next interval is going to be from 5/2 to infinity. And then just for the same reasoning as the other one, we need to include 5/2 using the bracket, because this also had, of course, the or equal to in the inequality, and then it is done. These are the intervals that satisfy that inequality. Okay, let's see a few more. Take a look at this one, 4x squared less than or equal to 1 minus 2x. So once again, we want to get everything on the same side of the inequality, and it's not always going to be on the left side of the inequality, but the x squared term is positive already on the left. So let's move these two terms to the left using addition and subtraction. So we're going to subtract, or let's do the 2x first. We're going to add 2x to the left, and then we're going to subtract 1, and that's going to be less than or equal to 0. So we just moved everything to the left-hand side. Now we're going to go ahead and create or find our boundary points. We're going to take this function here and find the x-intercepts. So we set it equal to 0. And then for this specific one, you could try to factor if you want, but I'll even just tell you now, this one does not factor. So let's just use the quadratic formula. So we know the quadratic, I'll go a little bit quick. It's x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So if you need to go back and take a look at the quadratic formula, make sure you have that memorized. And then when we simplify this down, we should end up getting negative 1 plus or minus the square root of 5 over 4. And then just kind of a side note here, it does simplify a little bit, so you might have to simplify this expression in order to get what I have right here. So even though this looks very messy, we're still doing the exact same thing. We're just going to draw a really rough sketch of the graph. And once again, this does not have to be perfect. You don't even need to have these x-intercepts in the exact, anywhere in the exact spot. So I'm just going to write it like this. Negative 1 minus radical 5 over 4. So that one obviously has to be on the left because that's the smaller one. And then on the right, negative 1 plus radical 5 over 4. And then we know once again, this is a parabola opening upwards. So it just looks something like this. Now we can go ahead and look at the graph to help us answer this inequality. So we want to know, when is this less than or equal to 0? Less than or equal to is below the x-axis or equal to the x-axis. So that's going to be this interval right down here. And that means our interval and interval notation is just going to be between these two values. Negative 1 minus radical 5 over 4, comma negative 1 plus radical 5 over 4. And then since this is an or equal to, we put a bracket on both of them to include it, and then it is done. So this one is a little bit different because our inequality was a less than 0, less than or equal to 0, which means it's just one interval instead of having to join two intervals together. Okay, next one. Let's do, I think, two more here. Solve 8 greater than or equal to negative 4x. So this one you probably recognize looks a little bit different. This is a linear inequality, right? The highest exponent for the polynomial expression is a 1. So it's a linear inequality. This is going to be a lot easier than a quadratic one. All we have to do here is solve for x. So to solve for x, we have to, of course, divide both sides by negative 4. But this is where we have to be very, very careful. When you multiply or divide both sides of an inequality by a negative number, you have to flip the inequality. So 8 over negative 4 is negative 2. But since we multiplied or divided by a negative, the inequality flips. And we have to do that every single time. So flip the inequality because we multiplied or divided both sides by a negative. And we're pretty much done. We just have x left over on the right. So we just have to write this in interval notation. So for me personally, I think it's a little bit more clear when we have the variable on the left-hand side. So -2 less than or equal to x is the same as x greater than or equal to -2. Just read it in the reverse direction and rewrite it. And then in interval notation, I'll just put or, because this is technically correct also, but if you want the answer in interval notation, x greater than or equal to -2 is going to be -2 to infinity, but the or equal to means we need a bracket on the -2. So -2 to infinity is the solution set for that inequality. So let's take a look at one more here. Just a little bit, hopefully not too bad, but a little bit trickier. So -8x squared greater than 8x. So a very common mistake that you see for not only inequalities, but equations in general, I see students like divide both sides by x and say, let's cancel the x. Never do that. Anytime you're solving an equation or an inequality, never divide both sides by the variable in order to cancel the variable. When you do that, it's going to be wrong. You're either getting rid of one of the answers or getting rid of like an interval or something. So never do that. Let's just follow our steps. Let's get everything on the same side of the inequality, so 0 is on the other side. This time, we have a -8x squared. We want that leading term to be positive, so let's actually add this to the right-hand side this time. So that's going to be 0 greater than, I'm just going to write this with the x squared term first, 8x squared plus 8x. And it's up to you, I guess. Once again, I like the variables on the left, but you don't have to write it like this. I'm just going to rewrite it as 8x squared plus 8x less than 0. So these mean the same thing, right? I just rewrote them, flipped which side they're on, and just rewrote it. If you do that, just make sure you flip the inequality as well. And now we do the exact same thing that we were doing. We're going to take that expression, think of it as a function, and find the x-intercepts or boundary points by setting 8x squared plus 8x equal to 0. And this one is just a plain old GCF factoring. We factor out an 8x as a GCF. We're left with x plus 1. Set both of those factors equal to 0 separately. We get x equals 0 and x equals -1. So drawing the little rough sketch for this one, we have 0 and -1. Once again, this is a parabola opening upwards, as it pretty much always should be, because we always make the x squared term positive. And going back to the question, we want to know, when is this less than 0? So less than 0 is going to be when it's below the x-axis. That's going to be over this interval right here, which is just -1 to 0. And then since this is not an or equal to, they just get parentheses. So we have a solution set. Any x value between -1 and 0 is going to be a solution to this inequality. Okay, I believe, let me just check. Yep, so that's the last one. So once again, we're only going to be dealing with either linear inequalities or quadratic inequalities. So theoretically, if you can do these ones, you should probably be good with any question that can get thrown at you. Right, so that is it for chapter 3.6.